What is mass actually? Think of a small pebble and a large rock. The rock is much harder to push, much harder to lift. The reason is that the rock has a higher mass, and in this case we can think of the rock as containing more stuff and hence having more mass. Now you already know that some particles are point-like, for example the electron. They do not occupy any space at all and hence cannot contain stuff. But then, how can they have a mass? It is the Higgs field that gives mass to point-like particles. How does this work? The Higgs field is everywhere around us, even though we cannot see it and cannot feel it. It is a bit like air, only that it is really everywhere in the universe. Now, while we do not feel the Higgs field, most particles can actually feel it. They stick to the Higgs field when we try to push them. They become harder to push or lift, which is just the definition of having a mass. How do we know that the Higgs field is there if we cannot feel it? A possible consequence of the Higgs field is the existence of Higgs particles called Higgs bosons. I told you to imagine the Higgs field as being a bit like air. If you disturb the air around us by clapping your hands like that, the air wiggles, waves form, and the sound that we hear is nothing but this wave moving through air. We can also disturb the Higgs field, for example by smashing two very fast protons together, as we do at the Large Hadron Collider. Every time this happens, there is a small chance that a wave forms in the Higgs field, and this wave then is nothing but a Higgs particle. This Higgs particle almost immediately decays to other particles, which we can then see with the help of huge detectors.